In this video, we'll begin to work with Chapter 3, Section 5, which concerns graphing linear equations in slope-intercept form. And if you recall, in the last section, we worked with linear equations in standard form, that is, ax plus by is equal to c. And we had an example there that, say you had $36 to spend at the movies with your friends on either drinks, which cost $4 each, or popcorn, which cost $6 each. Then you might have the equation 4x plus 6y is equal to 36. And we saw that when we had an equation in standard form, it was easy for us to graph it by simply finding the x and y intercepts. And you recall that the x-intercept is the point on the graph where the line crosses the x-axis. And at that point, y is always 0. So in our example equation above, if y were 0, we would have the equation 4x is equal to 36, or x is equal to 9. And that would give us the point x is 9, y is 0. We could also find the y-intercept easily when the equation is in standard form, because the y-intercept is the point on the y-axis where the graph crosses the y-axis, and at that point x is always 0. So if we were to set x equal to 0, we would have the equation 6y is 36, or y equals 6, and that gives us the point x is 0, y is 6. If we plot those 2 points on the graph, draw a line through them, and we would be able to easily graph the equation 4x plus 6y equals 36, and then go on to analyze what that equation is telling us. It would give us all the different solutions of drinks and popcorn that we could buy for $36. Now, if you notice what we just did, to find the x-intercept, all we did was divide the 36 by the coefficient, that is the number we multiplied x by, which is 4. We divided 36 by 4, and we got the x-intercept. Now, in the general form, ax plus by equals c, 36 is the c, and the number that's multiplied by x is a, so that means that the x-coordinate would be c over a, and the y-coordinate would be 0. That's the x-intercept. The y-intercept, where x is equal to 0, would simply be the 36 divided by 6, the number multiplied by y, and that in our general form of the equation is b. So if we were asked to describe the graph of the equation ax plus by is equal to c, we could simply say that it is the line, straight line, that passes through the points c over a, comma 0, and 0, comma c over b. That's how we would describe that line. In the case of our specific example, it would be 36 divided by 4, or 9, comma 0, and 36 divided by 6, or 6, and that would be 0, comma 6. So it would be the straight line that passes through those points. Well, similarly, here we want to describe the graph of the equation y equals mx plus b. Well, y equals mx plus b is just another form of a linear equation. Any equation can be written, any linear equation can either be written in standard form, ax plus by equals c, or it can be written in slope-intercept form, which is y is equal to mx plus b. And the question that we want to wrestle with in this section is, how can we describe the graph of the equation y equals mx plus b? And let's just recall for a second that m is equal to slope, or M is the slope, and B is the y-intercept. So how could we describe a graph if we know its slope and its y-intercept? How could we describe the graph of a straight line if we know its slope and its y-intercept? And so that's what we want to be able to work with in this section. And we're going to do three things. Number one, we're going to find the slope of a line, and we're going to do that two different ways. We're going to do that using graphs, as we'll see in just a second, and we're also going to do that using the formula y2 minus y1 over x2 minus x1. So we'll calculate slope or measure slope using graphs, and we'll also do it using the formula y2 minus y1 over x2 minus x1. And finally, we're going to use slopes and intercepts to solve real-life problems. So before I go on to some specific examples, let's talk about what slope is. And in this simple sentence, in these two simple sentences that follow, we have some great definitions and important terminology that relate to slope. And the first one is that slope is a rate of change between any 2 points on a line. Slope tells you how much the y is changing as x changes. How much y is changing when x changes by a certain amount. That is what we call a rate of change. How fast, how slow, is it going up, is it going down? How fast, slow, up, down is the y changing as x goes up by 1, by 2, etc. So that's what we call a rate of change. So slope is a rate of change. Second of all, slope is the measure of the steepness of a line. So when a line is very steep, we'll expect the slope to be very large. When a line is not steep, we expect the slope to be very small. The slope will also tell us whether the line is rising from left to right, it will be positive in that case, or falling from left to right, and it will be negative in that case. And if it's neither falling or rising, it's horizontal, then the slope will be 0 in that case. And we'll also look at some other examples of one other example. When the line is completely vertical, then we'll say that the slope is undefined. But we'll get to that. Now, many students do know or have heard that the slope is rise over run. And that's great, except that the words rise and run don't really have any information. Students can still misunderstand slope just by using those two words. So perhaps it's better to say that slope is the change in y over the change in x. It's the change in y over the change in x. It's the ratio of the change in y to the change in x. How much does y go up or down as x changes, increases? So that's what we're going to be measuring, and I'll stop this video at this point. Well, I'll point out one more thing. I'm going to use the strategy that, if you notice in this graph to the right, we have the graph that passes through the origin and also passes through the point 2, 3 and 4, 6. So, and you notice that in the book they measure the horizontal change first and then the vertical change. But I think that since the slope is the ratio of the change in y to the change in x, I would prefer to first measure the change in y. So in this case it would be up 3 and then over 2, and so we would say that the slope is 3 over 2, positive 3 over 2. And so I'll be using that. It may be slightly different than what's in the book, but I think that that is going to help us not make the mistake of putting the change in x over the change in y. All right, so I'll stop this video at this point and we'll actually get into some examples.